The definition of the three-component mixture, so three univariate components, starts in line 71. We have three mean values, three standard deviations, and three component proportions that again have to sum to 1. The following graphical representation, analysis, correction of label switching, and so on is exactly the same as we have done before with the two-component mixture. So let me skip directly to the results. So we see the true components and the true mixture in figure 3. The coloring of the components from left to right is blue, magenta, green, and the PDF of the mixture is the fat, the thick red line. Now for the fit. The histogram shows the data simulated from this mixture, and superimposed we see the fitted components. Their sum is the PDF of the fitted mixture, drawn in red, and the PDF of the true mixture is drawn in black. We see quite good agreement between the two, maybe with exception of the region of overlap between the central and the rightmost component. Now, what about the possible label switching? Well, the true components are colored from left to right, blue, magenta, green, and the fitted ones are colored magenta, green, blue. So there has been label switching. Now let's have a look at this association of the data to the components. You see in figure 31 that the order is magenta, green, blue from left to right, and this we see reflected in the associations of the data to the fitted components, with some overlap, of course. So after correcting the label switching, we can have a look at the correct permutation. Well, for this I have to interrupt here. Let's have a look at the permutation. So it's 3, 1, 2. So this is permutation that has been used to correct for the label switching. And after label switching correction, we can have a look at the confusion matrix. Most of the entries are in the diagonal. So there are in total about more than 96% of correct associations and close to 4% of wrong associations. This has of course to do with the fact that the components in the mixture are pretty well separated with not too much overlap. The larger the overlap, of course, the worse gets the confusion between components. Now let's look at my last example, which starts at line 76. So now we have 4 mean values, 4 standard deviations, and 4 component proportions. Let me skip again to the results. The procedure is the same in each iteration, independent of the number of components. So let's just skip to the end. So figure 4 shows the true mixture with now 4 components labeled or colored from left to right, blue, magenta, green, cyan. Here we have the simulated data in the histogram and the fitted components and the fitted mixture. Also showing the true mixture PDF in black. Here we see the association to the fitted components. And here we see the Lego plot of the true labels versus the associated, the found labels, corrected for label switching. And we see in the command window again the confusion matrix with most of the entries in the diagonal. This means there are close to 88% of correct associations of data to clusters and about 12.5% of wrong associations. So this terminates this video. In the final assignment, you will have to solve a clustering problem with bivariate mixtures. Apart from the correction of the label switching, the procedure is pretty much the same as in this video.